So let's work on finding an antiderivative with respect to x for each of the following terms. So trying to think about it backwards, if we have a value that has no x on it, we can kind of think back to what we just did up here. If it's just a number with no x attached to it, that means that your original function was an x, right? If y equaled x, then y prime would just be 1, right? So you can do the antiderivative here and say, oh, well, the antiderivative is just x, right? It's x. If we found the derivative of that, it would just be 1. But we also need to remember, hey, there's some sort of constant here that we don't know what it is. It could be an infinite number of numbers. And so we just need to account for the fact that there will be a constant on the original, right? On the original function. By putting that plus c at the end. Okay. So when we're thinking about it in this guy, when we're finding the derivative, we tend to go down. We always go down 1 power in our exponent, right? And so if this is an exponent of 1, we would assume, oh, well, then if y equaled x squared, then we would get down to a power of 1, right? But just realize that y prime of x squared is 2x, right? It's not just going down in a exponent. You're also then multiplying that exponent to the coefficient. And so with that, we need to realize that, oh, it's not 2 in front of here, it's 1. So we're doing half of this guy. So I'm going to do 1 half times 2x. Sorry, 1 half times x squared. Because 1 half times 2x would get us to x. So we're going to do 1 half times x squared, which means that our antiderivative, our integral, would be 1 half x squared. You can always do like a quick double check of like, oh yeah, let me find the derivative of that. It would be 2 times a half, which is 1, and then 1 less than 2, which is 1. Fantastic. Plus c. Always, always, plus that c at the end, the constant we don't know about. All right, so let's try it again. We've got x squared. And again, we would say, okay, well, if y was equal to x cubed, then this would be, then the derivative of that guy would be 3x squared. But the derivative is x squared. So we don't want 3 out here. We want just 1. So we're going to find a third of this guy. Our integral, our antiderivative, is 1/3 of this. Plus c. So hopefully now we can kind of see a pattern of what's going on when we start to find these derivatives, that we go up by 1 in our exponent, right? That's something that feels familiar from our power rule when we found derivatives in the past. And now it's not just going up by plus 1, we're also dividing by what is our new exponent. So thinking about that, the pattern that we've established that, okay, well, the derivative is going to have plus 1 in the exponent, and we're also going to divide or multiply by 1 over our new exponent. So 1/4, or divide by 4, right? So we brought that up by 1 and we divided by our new exponent. And we put plus c. Plus c, plus c. All right. Let's see if you can try this last one on your own. We go up by 1 in the exponent, so that's to the 5th power, and it's 1 over 5, right? We're dividing by 5 here. We can always do a quick double check. 5 times 1/5, 1, boom. 5 minus 1, 4, awesome, done. Except for we need to also put plus c. First time on your own, did you remember or did you forget? Okay. There is a rule for this. It's the power rule for integration. Just like how we only learned the power rule for finding the derivatives, there's lots of other rules for finding integrals, but this is the only rule that we will be held accountable for in this class. So for a function of the form f of x equals x to the n. We realize that this could have some sort of coefficient like ax to the n, but just realize that it'll just multiply in like it did with the derivatives before. The integral. So we have a really cool notation that we're going to learn. Remember when we learned our sigma notation, the like fancy E notation? And I was like, guys, this shows up in like all sorts of movies when you're like, I'm going to look all fancy and mathy, and the people who do the set design will like write sigma notations everywhere. This is another notation that you will see everywhere in movies when they're like fancy math things are happening. And it's this like weird S deal. You can see it below here. And it's just the integral symbol. It just means to find the integral. And we would do the integral of x to the n dx. With respect to x, it's like this weird, this is the official notation of finding the integral with respect to x. That's all that it means. And our rule is, okay, we would do x and then one more in the exponent, and then we would divide by whatever our new exponent is. And we would also do plus c. So just taking that exact same pattern that we noticed in the previous page and now just turning it into a formula. This is the power rule for finding the integrals. So when we move on and we now are asked to find the antiderivative in general form. In general form just means, hey, plus c, right? That's all it means. Like, give me the original equation or give me the final equation. In general form just means like there should be plus c at the end. That's it. Okay, so the integral of 4t with respect to t is going to be equal to, well, we've got this 4 and we just can kind of like keep it on the outside and then just focus on the t part. Because what's going on with the t is we're going to go up by 1 in the exponent. So that 1, that invisible 1 that's up there in the exponent is going to go up to 2. And then we do 1 over 2. We divide by 2, right? And then there's plus c. 4 times a half is going to be 2t squared plus c. And that's it. You just found the integral. Let's try it again. The integral of 3x squared with respect to x is going to be equal to 3 times, okay, x squared. We need to go up in an exponent, x cubed, and then we need to divide by that new exponent, 1 over 3. And then we just need to make sure to do plus c. 1/3 times 3 is going to just be 1, which is beautiful. So we've just got x cubed plus c. The integral of 14 with respect to t, this is a nice way for you to see the importance of having this part at the end of them telling you like, hey, the variable is t here. So just keep that in mind. Is going to be 14. And then if there was no t here, you can kind of, sometimes when I struggle with these guys, I think about it as 14t to the 0. Right? If it was t to the 0, it would just be 1, so it just goes away. So there is no t. So t to the 0 plus 1 would be t to the 1. And then we would just do 1 over that new exponent, which is 1, and then plus c, which is a whole lot of writing here that we don't actually need to write, but kind of helps us with our thought process, maybe. Who knows? 14 times 1 is 14. T to the 1 is just t, and then plus c, because we don't know what constant is going on there that just disappeared. I would like for you to try to do D on your own.